Okay, so in the last video I went over adding and subtracting simple polynomials. Here I'm going to continue that idea with division and show a couple of examples that help us to understand some of the more complicated problems. So again, if you have a to the third power over a to the second, this means you have a times a in the numerator and a times a in the denominator. Splitting this up, I mean, this won't change the answer here, but I'm just rewriting this a little bit. What do each of these equal? What is it every time you have a divided by itself in a fraction? That's what this fraction means. You get 1. Same thing here. So the only thing that would be left in this case is just a. And the shortcut that we start to ask people to see is that, well, isn't 3 minus 2 also just 1? And doesn't that equal a to the first? Just because we have 1a? And the answer is yes. So we can take a general case here, a to the m divided by a to the n. That will have to equal a to the m minus n. And that's a critical law here to deal with some of these problems. So let's look at a few. What if we had a to the negative fifth, b to the third, x to the negative fourth, and y to the seventh? Well, in other videos we talk about what these negative numbers really mean. They mean division, and really, in effect, if I move this up here, I get x to the positive fourth, and if I move a down here, we get a to the positive fifth, which is friendlier to deal with. So let's do that. We'll switch those up. Now we have x to the fourth power times b to the third over a to the fifth, y to the seventh. Right? We've rewritten this problem in this way to help us simplify a little bit. So now, what do we have? Well, I feel like we can't really go much further here because there's nothing really to simplify or divide. We don't even have two of the same variables, which is unfortunate. But anyway, if we look at another problem, I think we'll see a little bit more about what's happening here. And that problem is this. It's w to the second times w to the fifth to the negative third power over w to the third to the negative 1 times w2 to the negative fifth. So again, a concept that we go over in other videos is that these negative exponents here will just invariably switch whatever side they're on. So if you have an exponent raised to a negative power in the numerator, that will go to the denominator, and vice versa. We bring these denominators up to the numerator. So anyway, going this way, if we do that, we rewrite this as w2, w to the second, times, and then we brought this up, w to the second, negative fifth, over w3 to the negative 1 times w5 to the negative 3. To positive 3 because I switched it. Sorry about that. We still have to move this one, as you realized, up to the numerator up here. Circle that different color. This one right here, up to the numerator. So to do that, let's just switch this right now. We have w to the second times w, and I'm sorry, this should be positive because we moved it from down here. We switched it. W to the second times w to the second to the fifth power times w to the third to the positive 1. Right? All of that now being moved to the numerator, and that's over w to the fifth to the third. Now in other videos we talk about that when you see this happen, right, an exponent to an exponent, you multiply. So now you have w to the second, and here you multiply, but that's just going to be 3 times 1 or 3. So I'm going to add that over here because eventually if I multiply these two numbers with the same base, I would add the exponents. Right here we multiply the exponents, so that's times w to the 10th. In the numerator we have w to the 15th because we're going to multiply those as well. Now w to the 2 plus 3 is w to the 5th times w to the 10th. And they have the same base. So we can add those exponents and get w to the 15th and then divide it by w to the 15th, which is 1. So all this stuff boils down to a nice simple answer of 1, and that's often really a nice solution to reach in mathematics. Alright, hope this helped.